All right, so now that we've learned what a polynomial is and how to add and subtract them, now we're going to start getting into how we multiply polynomials. So the first thing we'll talk about is how we multiply a monomial by a polynomial. That is our learning target. Take a look at this picture. How many candy hearts do you think are in the bag? All right. So how do I multiply polynomials? We'll break this into two parts. We'll start with monomials times polynomial. So a review about exponents. What does 3 to the 4th power really mean? Okay, so we know that this really means 3 times 3 times 3 times 3. Okay, and that same thing is what does x to the 4th mean, right? Well, if the base is still a variable, this still means the same thing, right? X times x times x, just with an x instead of a 3. Okay, so if I want to know what x squared is times x to the 3rd, okay, I could write this as x squared as x times x. It's multiplication, so this is still times right there, and I could write x to the 3rd as x times x times x. So now, what do I get? Well, how many x's do I have? It's all multiplication still, see, right? So I have 5 x's, so my answer here would be x to the 5th power, right? There's 5 x's here, so I can rewrite this in condensed form as x to the 5th power. All right, well, how about this? I have x times x times x times x is x to the 4th, and times, there's 6 x's here, so I'm going to write 6 of them, and now I can just count to see how many I have total, right? Looks like I have 4 and 6 there, that's 10, so this is equal to x to the 10th power. Okay. And as we continue this, you can probably start to see maybe a shortcut here that I could do. X to the 3rd times x to the 3rd. I now have, that's a total of x to the 6th. Okay. And, you know, a reminder, like if I have x times x to the 3rd, well, x is x to the 1st power. Remember, this is really 1. And this would be, so I get x to the 4th. Okay, now in all of these, you can probably see a shortcut, right? I've got x squared times x to the 3rd, I get x to the 5th. X to the 4th times x to the 6th, I get x to the 10th, etc. As down the line, you're probably noticing here, if generally speaking, if I'm taking two things, as long as they have the same base, remember this is the base, a shortcut way of doing this would just be take that and add the exponents. You'll notice that throughout. X squared times x to the 3rd is x to the 5th, 2 plus 3. Okay, x to the 4th times x to the 6th, I could go 4 plus 6 and just shortcut, instead of writing it in this expanded notation, which every time, if we have larger exponents, that's going to take a while. So this would be a shortcut way, and this is a little quicker way of getting our answer, okay? So we're going to try to use that. So again, kind of keeping in mind our rule. Okay, that's times. Now remember, you might see a time sign in here, or you might see them written in parentheses. That still means multiplication, right? So, okay, if I'm multiplying these things, okay, this is really 6 times this. This is expanded notation. Now multiplication, you know you can rearrange these any way you want, right? I can move this all around and it's not going to change my answer. So I could rewrite this as 6 times 4 times x times x times x times x Okay, that's these 4 right here. Now I got these 3, so times x times x times x. Okay, so now this would be 24. 6 times 4 is 24. And then how many x's do I have here? Okay, that's x to the 7th power. Okay, so now a little quicker might be if we go back up here and look. What we could do is just say, all right, I got these 2 things. I'm going to multiply those. That's 24. These bases are the same, so I can add the exponents as long as the bases are the same, okay? So then that would give me the same thing, but a lot faster, right? And now we end up with the same answer. So that's kind of what we want to use, is then we can use this property a little quicker and get our answer. Okay, so that's what we're going to try to do. So now let's look at this. Remember, I've got parentheses, and that means multiplication here. Really, this means multiplication. We don't usually use the x for multiplication anymore because it can be confused with a variable, right? So, okay, so I'm going to say, really what I want to think of is -5 times -7, and then I've got y to the 3rd and y to the 5th. Now notice this is all of these are being multiplied, but this is kind of how I want to think about it. So -5 times -7 is positive 35. And now we just learned, how do we do this? Well, the bases are the same, they're both y. So that means the shortcut would be to add the exponents. So this would be y to the 8th. Now remember, this does not mean you're adding. Notice there's no addition sign anywhere in here. This is just a shortcut. Rather than writing y to the 3rd out 3 times and then y to the 5th 5 times, you can just do that. So my answer would be 35y to the 8th. So what does that mean? 35 times y to the 8th power. Okay, so, oops. So I hope that makes some sense. So now let's take a look at this. This kind of problem here, you would think 3 times -9. Now you can do this in your head. I'm just going to write it out. Now all this again is multiplication. So I'm going to put my x's together because I know I group those because they have the same base. Okay, and then times my y's together because they have the same base. Okay, now I can't put x's and y's together, but I can put x's together and then y's together. So that's what I'm going to do. So first, 3 times -9 is -27. Again, the shortcut for this, putting these together, would be add exponents. Remember, this is really a 1, so this would be x to the 4th. And then this, now I'm going to put these together. So this would be y to the 8th, 2 plus 6. Okay, so this would be my answer. And notice they're all together. Again, this is all multiplication, so that's one term. That's a monomial times a monomial. Okay, so that's how you do those problems. You'll notice that's how that works. Okay, now let's talk about distributive property. If you recall from last year, distributive property, this is A times the quantity B plus C. Okay, so shortcut to figure this out is what you did is you multiplied A times B, you got that, and then you did this, A times C, and you added them together. Okay, so this is called the distributive property, and we're going to use that right here. Okay, so now we're taking a monomial times a polynomial now. Okay, so what we're going to do is we're going to start by multiplying these two. Okay, so I'm going to say 7 times 4 first. That's 28. And now I want to think about my x's. Okay, x to the 3rd and x squared is x to the 5th. Okay, so that's my first term. All right, now I'm going to take and distribute, and we'll use a different color so it's clear about what we're doing here. Now we're going to do this. Okay, we're going to take this monomial times the second term. So 7 times -8, you want to think about that again as a -8. It's multiplication each time, so this would be -56. Okay, now I'm going to think about my x's. So x to the 3rd and times x, I'm going to add those exponents, right? So this would be x to the 4th. okay? And that term's done. Now notice there I put a plus or minus sign in between. Every time you do a multiplication here, you should have a plus or minus sign in between. Okay, and then lastly I have this, right? So this is 7x to the third times 3, and you can write that out here if that helps, but that's really what you're doing. And so I have 7 times 3 is 21. It's positive, so I'm going to put a plus sign right there. Okay, and I have 21, and then x to the third. I don't have any x's here, so just x to the third. Now you want to make sure your answer is in standard form. Okay, I've got a degree of 5, 4, and 3, so yeah. Okay, so that means my answer is right here. 28x to the fifth minus 56x to the fourth plus 21x to the third. Okay, that's how you multiply a monomial times a polynomial. Let's try another one, kind of make sure we're okay. This is a little weird because it's got 2 variables in here. The process is going to be the same though. Okay, so we're going to go like this. Okay, and if you again need to write it over here, negative 3a to the third b times negative 5a squared b to the third, and figure out what that is first, and then rearrange them, you can. So this would be negative 3 times negative 5 is positive 15. I'm going to look at my a to the third, a squared. That's a to the fifth. Remember adding exponents there. Okay. And now I'm going to do b. Put those together. That's b to the first power. B to the third is b to the fourth. So I end up with 15 a to the fifth, b to the fourth. Okay. Now again, you don't have to write this out every time if you can do this in your head a little bit, but that might help you if you want. So it's whatever makes the most sense to you, use it, right? Okay, so now let's try, we're gonna do this monomial times this. So you notice you're doing negative 3a to the third b times each of these terms in this polynomial. Okay, so now I'm on the middle one. So negative 3 times 8, that's going to give me a negative 24. So I'm going to put minus 24. Now I'm going to think about the a's. Okay, a to the third times a to the third is a to the sixth. Okay, and now I've got the b's. B, remember this is a 1, that's a 1. So b to the first times b to the first is b to the second. Okay. All right, now we're going to do negative 3a to the third b times this last one. Okay, again, watch the sign. That's a negative, right? So negative 3 times negative 6 is positive 18. So I'm going to put a plus sign. Okay, and now a to the third and a. This is a 1, this is a 1. In case if you need to write it in there, do it. So this is a to the fourth. And now look at the b's. So b to the first, b to the first. So that's b squared. Okay, and this should be my answer, but you want to make sure it's in standard form. So look at the degree of this. You're going to look at the exponents, 5 and 4, that's a degree 9. This is a degree of 8, and this is a degree of 6. So is it in standard form? Yes. So I'm going to leave it like this. And this is how you multiply a monomial times a binomial. This is kind of like the trickiest type of problem you're going to see. All right. So now that is your assignment, multiplying monomials by polynomials. Don't forget to write it into your student assignment book, into your planner, and then check it off once you turn it in. All right, bye.